Hello friends and welcome back to this series on random variables on your channel GATEquestionsECE. So the next question is having question code 114. Consider three independent and identically distributed random variables x1, x2 and x3 such that x1 is distributed uniformly over range 0 to 1. If z is equal to maximum among x1, x2, x3, then find the PDF and CDF of z, probability that z is less than equal to 1 by 2, expectation of z and variance of z. In this question, it's not given that x1 is discrete or continuous. Whenever in question it's not given, then by default it will be a continuous random variable. So let's see how to solve this question. From the previous discussion on the maximum function, we know that if z is equal to maximum among n random variables x1, x2, x3 up to xn, then the CDF of z will be given by fz sample value small z will be equal to the joint CDF of all these n random variables x1, x2, x3 up to xn with sample value z, z, z up to z. So all these random variables have sample value small z. That is the relation between the CDF of z and joint CDF of all these n random variables. Moreover, if all these random variables are independent up to xn are independent, then we know that the joint CDF of z will be nothing but the product of marginal CDFs of all these n random variables. Fx3 z product of all CDFs of these n random variables. So this is the relation for independent random variables. Moreover, if these n random variables are identically distributed, then we can write that these n random variables are independent and identically distributed. Then the CDF of z in that case will be, so in that case the CDF of z will be equal to f of x1 of z raised to power n. So this is the result for i.i.d condition, that is all these n random variables are independent and identically distributed. When they are identically distributed, all these CDFs will be equal. So in place of each of these CDF we can write fx1. So this will become fx1 raised to power n. Assuming all these n random variables are continuous random variables, we can easily obtain the PDF by differentiating with respect to z on both sides of this equation. The PDF of z, so differentiation of this CDF will be this PDF will be equal to, for differentiating this function with respect to z, we will get n times the CDF of x1 raised to power n minus 1 times the differentiation of CDF of x1. So differentiation of CDF will be its PDF. So this is the end result that we have derived many times in previous discussions also. So these two are the end results for i.i.d case, that is independent and identically distributed continuous random variables, where z is maximum among all these n random variables. So we will be using these two results in the part A of this question. So let's see how to solve part A. So in part A, he has asked to find the PDF and CDF of function z is equal to maximum among three random variables x1, x2, x3. Also, it is given that x1, x2, x3 are independent and identically distributed. That is, it is a case of i.i.d. random variables. Also, x1 is uniformly distributed over range 0 to 1. Since all of these are identically distributed, so x2 will be also uniformly distributed over range 0 to 1. Similarly, x3 will be uniformly distributed over range 0 to 1. So, for this case of i.i.d, we know that the CDF of z will be equal to the CDF of x1 raised to power n. But here n is 3 because here in total there are 3 random variables. So, it is raised to power 3. So, the PDF of z we can get by differentiating both sides with respect to z. So, it will be equal to, so differentiation of this will be 3 times the CDF of x1 raised to power 2 times the PDF of x1. So, now what we have to do is find out the PDF and CDF and then put the equations of those in these two formulas. So from this we know that the PDF of x1 will be equal to, so it will be equal to 1 when z is greater than 0 but less than 1 and 0 otherwise. And also we know that the CDF of x1 will be nothing but the integration from minus infinity up to z of the PDF of x1. So here I am taking a dummy variable lambda d lambda. So in this integration we perform over this function, we will get that the CDF of x1 will be equal to, so it will be z for range 0 greater than z less than or even equal to 1 and 1 for z greater than equal to 1. So you can perform this integration by yourself and you can observe that this is the PDF and this is the CDF for x1, x2 and x3. Here I have calculated only for x1, but because they are identically distributed, so formula for the PDF of x2 and x3 will be the same. So now we can easily obtain that the CDF of z will be equal to, so it will be cube of this. In this range we cube this. So it will be z cube for range 0 to 1 and for z greater than equal to 1 it will be 1 and for all other values of z it will be 0. Now similarly from this formula we can calculate the PDF of z. So it will be 3 times the CDF of x1 squared. So firstly we have to square this function and then multiply it with the PDF of x1. So we will get that the PDF of z will be, so 3 times square of z, it will be 3 times z square in range z greater than 0 less than 1 and for all other values it will be 0. So this is the PDF of Z, and this is the CDF of Z. So now let's see what will be the solution for part B. So in part B, he has asked about the probability that Z is less than equal to 1 by 2. So this will be equal to area under PDF from minus infinity to 1 by 2 under the PDF of Z, dummy variable lambda d lambda. So this is nothing but the CDF of Z calculated at Z is equal to 1 by 2. So you can use either the CDF formula here or the PDF formula. If you use CDF formula, from the CDF you can observe that by putting Z is equal to 1 by 2 in this equation, we can get that the Fz of 1 by 2 will be equal to 1 by 2 cube. So the answer will be 1 by 2 cube, which is nothing but 1 by 8. Similarly, you can use the PDF of Z here and calculate the integration. So it will be from minus infinity to 0, the PDF is 0. So we can directly write 0 to 1 by 2, and the PDF is 3z square dz. So it will be 3 times z cube by 3 values 0 to 1 by 2. So 3 will cancel out and answer will be again 1 by 2 cube. So the answer to this probability is 1 by 8. You can use either the CDF method or the PDF method. So now let's see part C of this question. In the part C, it is asked to find the expected value of Z. And from the formula of expected value of Z for continuous random variable, we know it is equal to integration minus infinity to plus infinity sample value Z times the PDF of Z dz. And also in part A solution of this question, we calculated that the PDF of Z is 3 times Z square in range 0 to 1, and otherwise it is 0. So putting this function value here, we will get integration will be from 0 to 1 Z times, so the function is 3z square, so into 3z square dz. So it will be 3 is constant, it will come out of the integration, and integration will go from 0 to 1 z cube dz. Where it is small z, everywhere it is integration is small z. So it is 3 times z raised to power 4 by 4 0 to 1. So it will be 3 by 4. So 1 raised to power 4 will be 1 and 0 will become 0. So 1 minus 0 will be 1. So this is the answer to the expected value of Z. So in the next part, he has asked about variance of Z. So let's see how to calculate the variance of Z. So in part D, it is asked to calculate the variance of Z. And from the definition of variance, we know it is nothing but the expectation of Z minus Z bar square, where Z bar is nothing but the expectation of Z. So this we have calculated, already we have calculated in part C of the question, and also this is equal to expectation of Z square minus expected value of Z raised to power 2. From the part C of the question, we know this is equal to 3 by 4. So putting here this value, so it will be equal to, variance will be equal to expectation of Z square minus 3 by 4 square, which will be 9 by 16. So now to calculate the variance of z, all we need to calculate is expectation of z square. So that we can do similar to the expectation of z. So expectation of z square will be equal to integration minus infinity to plus infinity z square times the PDF of z dz. So this we know it is 3z square in range 0 to 1. So the integration will go in that range only, from 0 to 1, z square times 3z square dz. So 3 is constant, it will come out of the integration. So it will be 3 times, integration will go from 0 to 1, and this will be z raised to power 4 dz. So this will be equal to 3 times z raised to power 5 divided by 5 and lower limit 0 to upper limit 1. So this will be again, it will be 3 by 5 only. So the expected value of z square is 3 by 5. So now we can put this value in this equation. So the variance of z will be 3 by 5 minus 9 by 16. So taking the LCM is 80. So it will be 48 minus 45. So that will give us 3 by 80. So this is the answer to part D. So I hope guys the solution to this problem will give you idea about how to handle the questions on maximum and uniform distribution, and also I will like to give you a problem for practice. So the practice problem is this problem, and I hope you will solve it, and please do post your answers in the comment section, or you can mail me the answers to this mail ID, or you can send me your answers to the Instagram account. The details of Instagram accounts are given in the description. So I hope guys you are learning and enjoying the video solutions. I'll be bringing more such videos in future. So please do press that like button below this video and subscribe to my channel for more such questions in the future. So thank you for watching this video.